In this lesson, we're going to talk about creating custom functions. And the learning objectives in this quick intro to custom functions is first, to create custom functions as standalone files and also subfunctions within a script. And second, to document the function in a help style for future users of the function. So we've already discussed how functions are a key building block in MATLAB by exploring several built-in functions. And after learning that syntax, now we can create our own function, and you can gain just an incredible amount of freedom to customize the logic and approach that you take for designing your own programs. So let's recall a little bit about the function structure that we used in our built-in functions. So for example, let's just type in help size when we're sizing an array. And remember, there's all kinds of good information here, and the structure of it is that we have the name of the function itself, and then we have the input of the function within the parentheses. And then on the left-hand side of the assignment operator, we have at least one variable output. Occasionally we have two variable outputs that are separated by a comma and in the brackets in the same way that we create our arrays. And keep in mind that any of the functions that we have or that we create can use any type of data or data types that MATLAB supports as either input or output, and that can be numeric, string, tables, just depending on what you need. And today we're going to focus on numeric data types. Now MATLAB gives us the ability to recreate this very same format with our own custom functions. And there are two types of functions that we have. The first are standalone functions, and these are separate M files, just like the scripts. They have the .m extension, and they can be called from any script that you're writing or also the command line. The second type are subfunctions, which are written inside of a script, and those are only accessible or callable by that particular script. We'll go over both of these momentarily. Let's start by creating a standalone function in which we're taking in the Cartesian coordinates of 2 points. And then we're taking those 2 points and finding the distance between them. So if we have point number 1 and then point number 2, wherever they may be, we have an x1 and a y1 with our x, y axes, and then x2, y2. And we want to find the distance between these two. So let's create a function that's called line length to perform this task. In these latest versions of MATLAB, we can then create a new function, which will open up a new window, and previously we would open up a script and then have to save it as a function. And so here we see some guidance, a template that we can use that starts out with function, which is the required command that we use, and then the template that we have are output argument 1 and 2 are equal to, and this untitled 7 is reserved for the function name, and then we have our input arguments. Let's enter our function name and then save it. We're going to call this function line length. The name of the file has to be the same as the name of the function. So notice that our function name is line length, and our file name also has to be linelength.m. Next, we'll fill in our inputs. And so we want to have 4 input arguments. An x1, we want to have y1, x2, and then y2. And then we have only one argument for our output, which will be distance. Now let's talk through what's going on here with this header. You can see it says Untitled 7, which was that template name that it gave us. Then summary of this function goes here, detailed explanation goes here. And so what this is doing is, if you recall, we just now pulled up help size when we were using the built-in function. If we type in help line length, then press enter, then all the text that we have here, Untitled 7, summary of this function, etc., fits in right here. And so this prompting is to help us fill in the details that is going to help the user of the function understand what the purpose is. And we'll get to that in just a second by going to our cheat sheet. And here I have the template that I recommend that you use, that we can just fill right in. Paste this in here. And so the name of our function is line length. It calculates the length of a line from point 1 to point 2 using Cartesian coordinates of each point. A synopsis line, where we have our distance is equal to our function, and then our inputs. I always recommend having this line here because one of the things that I find often that I do when I use help menus is I want to just copy and paste the input and output format into my script. And then the inputs are telling us what it is that the inputs and inputs mean. Here we've got the Cartesian coordinates of point 1, and then we have the Cartesian coordinates of point 2. And then for our outputs line, distance is equal to the distance from point 1 to point 2. So this gives your user a complete description of what this function is going to do and how to use the inputs and outputs. And now, after saving our function, we can clear in our command window, and let's do our help command. And you'll see that we have all this information in a nice format for your user should they need to know more information about how to use this function line length. And now we're ready to fill in the actual mathematics of the function to make this function calculate that distance. So we know that we need to output distance. So copy this down here, and so we need to come up with a distance is equal to something. The formula for the distance between 2 points in Cartesian coordinates is the square root of the quantity, the x distance squared plus the y distance squared. So let's create an x distance variable and a y distance variable. Our x distance will be x2 minus x1. We'll suppress the output. And then our y distance is y2 minus y1, and suppress that output. And then for our distance, it's the square root of our x distance squared plus our y distance squared. And then we'll suppress this output. Don't forget to save your function. And we've satisfied everything that we need to have here. We have inputs of x1, y1, x2, and y2. We use intermediate variables, x distance and y distance, as part of our final calculation for distance, which is necessary for the function output. So let's test our function in the command window we'll set length is equal to, and we'll grab our format here, line length, and for x1 let's put in a 1 and a 4, and then so that puts us in the first quadrant, and so let's put one in the second quadrant for our second point. So let's put in -2, gets us in the second quadrant, and then +7. And we get that our length of the line between those 2 points in Cartesian coordinates is 4.2426. And so to recap how to make a standalone function, you're going to do a new function, and it'll give you a template that you can fill in. I'll also give you a header that I recommend using that gives the synopsis, the inputs and outputs. You choose your inputs and outputs, come up with the mathematical or other calculations and coding that you need, and just make sure that you have an output of distance or the output that's equal to the variable in your function call. And then you will have a function that is linelength.m, so it's an M file that you can move around anywhere that you'd like or anywhere that you need to use this function that you've created. Now that you have an idea of how to use standalone functions, let's move to subfunctions, which are functions that are written at the bottom of a script to be called only within that script. So open up the Spring Forces with Subfunction Starter. And so here our goal in this script is to calculate spring forces that have for various springs and lengths of the springs. Now what we see in this script as it's defined is that we have properties of 2 different springs. We have spring 1 and spring 2. And the calculation for a spring force is pretty simple. However, if it's something that we have to do over and over and over, then it makes sense to, in this section down here, to be calling a function to calculate the spring force at these different lengths. And the lengths here are defined between 0.5 to 2.5 meters in half-meter increments. So what we'll do, instead of writing these calculations over and over, is that we'll create a subfunction at the bottom of the script. So at the bottom, I like using the double percent signs, which cordons off a particular section. We're going to make a spring force calculator function. And so for this, we're going to be using our function template. So function is equal to, and then remember we have our output arguments on the left-hand side. So it's going to be force is equal to, and we'll call this function the spring force calculator. And for our inputs, because our equation is F is equal to minus K times the stretch, our inputs will be K and then LS, which is the resting length of the spring, and then L. So notice I'm using some short variables here because we can define all that we need in this quick calculation. And we'll do this by placing some information right underneath the function call. And the key in all this is just to make sure that your user understands all of the calculations in detail and won't be confused when they're coming behind you and reading your code. So the next part, we need to define the force, which is our output. And we know that our force is equal to negative K times the stretch. So we have to define the stretch as L minus L sub S. We'll place an end, which closes out the function, the subfunction at the end of the script. And now with this information, we can come back up to the main body of our script and add the lines where we want to calculate the spring forces for spring 1 across these different spring lengths according to its stiffness of 50 newtons per meter and its resting length. So let's do that. We're going to use this form. And so the form here is going to be the force, and we want to give this a unique name. So this will be spring 1 force. And we're going to use our spring force calculator. We're going to give it the stiffness, K. And so to call it, we're going to give it spring 1 stiffness. LS is our resting length, so we'll give it spring 1 resting length. And then we want to give it a series of lengths, spring lengths. And so I won't suppress the outputs here, but let's run this script and let's see if it gives us what we want. We see that at the length of 0.5, it gives us an 85 Newton force. And then as we move through the 2.5 meter length, we get 5 different lengths that 5 different forces that correspond with the lengths. We'll repeat this process for our spring 2. Second spring, we need to change where we're storing this is to spring 2. We need to give it our second spring stiffness, our resting length of spring 2, and we're going to give it all the same spring lengths. So we'll clear our command window, run it once again, and then we see that our spring 2 force gives us a series of forces, an array of forces, 90, 40, negative 10, negative 60, and then negative 110. Those are the forces that correspond with these lengths from 0.5 to 2.5. And so this subfunction approach is when you just need a quick calculation that you're going to be using over and over. And as a reminder, come to the bottom and then type in your function. Output is equal to the function name and then the inputs that you need. Give those quick calcs and then use them anywhere within the body of the script. So in summary, these custom functions are incredibly helpful. We use them all the time in MATLAB. You'll find that they really affect the way that you program and give you the flexibility that you need to program in very creative ways and very structured ways that we'll be getting to in later lessons.